Project-based is the best way to learn because number one, you're creating a work product. Number two, you're learning about the bigger picture. And number three, you're delving into the finer details. Many times in mathematics, we jump right into solving equations without rhyme or rhythm. But there should be a reason. Why do we want to solve equations in the first place? Or actually, maybe an even more fundamental question is, how do we develop or construct those equations that we want to solve? This is what we want to delve into here into this project. What is the motivation for solving equations? Once we construct the equations, then we want to develop techniques to solve the equations. This becomes a general game or an abstract puzzle in mathematics. The main motivations for solving equations mainly come from physics and engineering and industry and business. In physics and engineering, the equations are derived more theoretically. In industry and business, the equations are derived more statistically. For example, in the category of physics and engineering, Newton invented calculus because he wanted to calculate instantaneous velocity. As an example, in industry and business, given a set of data points, people want to be able to A, predict the future or predict the past, and predict what happened between the data points. So this is one of the main motivations in all of science. We want to be able to predict the future. We also want to be able to know what happened in the past. What is the most common things we want to know day by day? The weather. There are a set of equations that predict the weather. So a company wants to be able to predict how much profit they will make in 5 years after selling 10,000 products. In physics, we want to be able to predict how far an object will travel, say, given its initial velocity and angle of launch. So given the angle theta here, and the initial velocity v0, we can predict the range, the horizontal distance, not the vertical distance. This denotes the horizontal distance that the object goes. And g here denotes the acceleration due to gravity. Here are some more applications of equations from economics. We have the marginal cost, we have economic order quantity, and then the third equation down there is from physics, special relativity specifically. So L0 here denotes the initial length of the object, c here is the speed of light, and v is your velocity, your current velocity. Now the speed of light is a constant and no object can move faster or even as fast as the speed of light. So v should be less than c. But see what happens if you plug in v equals c into that equation. See what the result is. The result you get is that L equals 0. So the length of an object contracts to 0 from someone else's perspective. Of course, if you're the object going at the speed of light, you still seem like you're just a regular person. But from someone standing on planet Earth, they're going to see your length contract very small. So here's the Desmos project. Create a linear and quadratic model, or regression, which is a function, for a set of data points. Make it 10 total data points that a business might be able to measure. You can make up the data points, make up the company, and the product they are selling. For example, the revenue could be the output Y as a function of the number of items sold, which would be the input X, or revenue could be a function of time. Questions you might want to answer in your presentation. What is revenue? What does a revenue function tell us? What is the name of your company? What does it sell or service it provides? What are the two revenue functions R of X you came up with? Can revenue be negative? Can profit be negative? Explain. How many items must be sold to achieve a revenue of $500? If you were able to do this, you just built your first equation. So here are some links to create the Desmos program. First, you need to create an account in Desmos at the URL using your Google email account to access your saved work. Then copy and paste the link of your Desmos program into your slides. And here we have a sample program that we can click on. So this is how you create your data points. Just create a table in Desmos, okay? And then you put in this line of code. And then it gives you the coefficients for the slope and the y-intercept of your linear regression or linear model line. Then here you have your revenue function. Okay, so this is very important. You may not understand everything, and that is okay. This project has a coding aspect, a math aspect, and a business aspect. Just do one step at a time, even when you may not be sure what it means. If I just showed you isolated skills, it becomes very mechanical, and thus meaningless. Projects allow you to learn skills in an organic manner, like, why are we doing this? You want to be able to see the big picture, otherwise it just becomes factory work. Alright, I hope you enjoyed this fun project on Learning Isn't Linear, and check out my book, Learning Isn't Linear, for more projects to do. If you are learning from the free resources from this channel, then you'll love my book, Learning Isn't Linear, available on Amazon.com. It contains crisp illustrations to accompany non-standard problems with extremely detailed solutions. The link is in the description. If you get the ebook version using the Kindle, there are clickable links throughout the book to Desmos and GeoGebra projects. It is very easy to search within the book for specific topics. As you can see, chapters range from algebra to calculus. Whether you are a self-motivated student solving problems on your own, or a teacher preparing for a math class, this book is a valuable resource to add to your repertoire. Okay, till next time, and remember, prioritize long-term learning over short-term test taking.